Good morning and welcome to the Cloud Automation Summit brought to you by Fierce Network. For those of you who haven't met me before, my name is Oliver Ward, conference producer at Fierce Network, and I'll be your host for this year's show. Before we begin, please allow me to thank our partners for this session, VULTR, Rakuten, Symphony, and Ribbon Communications for their support. As we start our first session, Understanding Automation Essentials, Challenges, Solutions, and Beyond, here is what you can expect. Kicking us off at 11 a.m. Eastern Time, Diana Goovaerts from Fierce Network is joined by Kirk from Microsoft as they start the session with their Fireside chat. Then at 11:15, we'll have our partner keynote by VULTR. Afterwards, Chua from AvidThink will lead the panel discussion as he is joined by speakers from Telenor, Open Infrastructure Foundation, Rakuten Symphony, and Ribbon Communications. Just a couple of housekeeping items. Please make sure you're submitting your questions to the panel using the Q&A tab at the top of the screen and using the network chat on the left to network with your fellow attendees. Also, make sure to check out our Partner Content Hub for any content provided by our partners, and then make sure you're joining the conversation on LinkedIn and X with hashtag Cloud Automation Summit. Lastly, please do look out for the post-event survey that will be sent to you after the show, as we do really value your feedback. So without any further ado, let's get started. Diana, the floor is all yours.
I'm so excited to be here today with Kirk, Global Sales Director for the Americas in Microsoft's Media and Communications Division. The chat ahead of us is all about automation essentials, everything from where to start and key tools to risks and the role of AI. thank you so much for being here.
Oh, thank you.
Great. Okay, so let's go ahead and jump right in. So how do enterprises decide what to automate when it comes to their cloud? Or put a different way, what should they be focusing on?
Well, I like to take a step back and really think about the people, process, and tools or technologies that they have in place. But, that makes up the culture, or what you call a profit formula of any organization. There's a mix of all three, and really to do automation properly, it needs to be a planned event. And typically organizations, starting off as a very small organization, they may be very informal. A much larger organization may have very formalized process like a transformation lead or a center of excellence in the organization. And that center of excellence has the necessary people, meaning whether they're business analysts and technical people, and a steering committee, if you will, that reports up into the executive leadership to help prioritize where in the organization they want to automate. But it's really having that center of excellence, and then now identifying and building that backlog of what is vital, what needs to be automated in the organization. Okay, what are the high impact areas? Where are the repetitive and time consuming patterns in the organization? And what are the key business processes or the value chains that make up the organization that is lacking automation, if you will? Okay.
So I know that we've spoken before about different layers of the organization to focus on. Are there any suggestions you have for where to start?
Well, in the core of every organization is the operations side of the business. So the operations, and then the front end side, which is really the marketing, the sales organizations as they interact with customers, to accelerate and build a robust pipeline and close deals, communicate with customers, all of the activities relative to a sales process. There's a lot of interaction that happens there, and so the more you can do to simplify the seller's daily activities and automate as much as possible relevant to how they interact, how they follow up with customers, how they develop quotations or proposals, and how they close deals going into a contract process. That's very important. That's critical because that's revenue focused. On the operations side of the business, this is about risk mitigation, about ensuring that your service to your customers is working properly all the time, and that you can drive self-service in terms of helping customers from a post-sales perspective to make adjustments to their plan, or give them capabilities to add on features, services without really having to call into the organization, contacting the contact center to be able to drive their own needs. So
And I
two
know,
areas, front end
yeah.
and the operations.
And I know Microsoft is big on collaboration. So is there anything that can be automated there?
Well, I mean, out of the box, Microsoft as an organization, we are automating, we call it Copilot, and that's basically Gen AI. And you'll see Copilot in every area of our solution family products. So whether you're using something like Teams or Microsoft Office, Word, Excel, PowerPoint, you name it, or Outlook in terms of emails. I mean, you're going to find Copilot all over there in our Dynamics area, which is really the business applications that drive the business. So the customer engagement, the CRM, the back end, meaning ERP, like finance, supply chain, and projects, program management, as well as services. Services really is twofold. It's the customer service, it's the case management, and then also in many cases in certain types of organizations, you have to go out in the field and touch the customer or touch a piece of equipment, and that's work order management. So we have Copilot in every area of our solution stack.
So I know we talk about automation all the time, making life easier, but getting to automation itself is not always easy. So what is the biggest hurdle that enterprises face when they're looking to automate their systems?
Well, many businesses use a variety of systems and applications to manage different aspects of their operation, and without proper integration or a common data layer, and data is key here. Data is that's the gold, or if you should say, it's the foundational layer that makes up an organization. It's all the data, all the transactional, all the insights, how they see their customers, how they see their partners, their vendors, supply chain from that perspective. So if you don't have a concerted focus in terms of your systems and applications and the interoperability of those applications across a common data layer, because that in the 90s, up until about 10 years ago, everybody used best of breed solutions, and each best of breed solution sat on a different data layer. And the challenge is knitting that data layer together so that way when you look at a customer record, you see the same customer throughout the entire business. And different silos create redundant records, and therefore it's a nightmare for organizations to manage. And then when you try to apply AI to that disjointed data layer, it complicates things even further. Okay.
So let's dig in on that AI piece. I mean, how can AI help when it comes to automation?
Well, from a business operations perspective, AI will improve decision making across the board. So, I mean, actionable insights, next best actions, revenue forecasts. But before you can implement AI successfully, it's having that data layer unified in a way that account records, vendors, suppliers, you name it, all of that data, all of those transactions are interchangeable, or they're connected, if you will. Then AI can come along that data and basically provide those actual insights or trends, to be able to make informed decisions. But it's about automating repetitive and time-consuming tasks. Really, that's what AI can do. Is if you look at the average worker and manager, and we all, including myself, we have certain work that maybe occupies 30% or 40% of our day, such as email management, calendar management. If I'm a procurement person, I've got purchase orders to manage. I've got to ensure that I've got delivery on time of those purchase orders, available to promise. So if AI can do a lot of that legwork and allow me to focus on what is really human-focused activity where I can truly add value, that's where AI can help dramatically today.
All right. So I know that data is very precious. And one of the things that we've talked about is, the risks associated with automation and AI. So I'm kind of curious what your take is on that, particularly when it comes to data, when it comes to having things like guardrails in place. What are those and why are they important?
Well, the operational and security risks, that's one side of it. Okay, so how an organization applies AI, and then there's data leakage or AI leakage in terms of the results of AI can be, can move into a different environment where others can see it, or people or personas that should not be seeing your data. So that's one type of risk that you got to be concerned with from an AI perspective. So you have to be careful on who you select for your AI, how that AI is developed and contained within your organization, within your data boundaries, and who has access to the results of the type of activities that AI generates. So privacy and security, is a key area for the data layer. Another side of it too is the cost and return on investment. Many organizations don't clearly understand how it's going to benefit them. I mean, think about really, it's been about 18 months and AI, Gen AI, all of the announcements that have come out, and organizations are trying to embrace this, trying to understand how they can embrace this in their organization. And it comes down to who do they select as that AI partner and the frameworks that AI partner has put in place already that can be consumable out of the box.
Okay. So I have a quick question that I ask almost everybody that I interview, and I get some pretty interesting responses to it. So what is one thing I did not ask you about that you think more people in the industry should be thinking about?
I want to say it's really, there's several points on the AI side of things. Okay, so this is about organizational embracing the concept and trying to understand where in their organization they can activate AI, a common data layer, to benefit that organization, that culture, because we have to really take a step back and look at who we are as an organization. How do we operate? What direction do we want to go in? And ensure that our tool sets, our technologies, AI being part of it, data being part of it, people and processes, that all comes together into a concerted whole. Okay. And so when we look at strategy, we have to look at high quality data is affected, on the backbone. We have to look at the workforce in terms of their mindset, embracing the change, having that growth mindset is important. Without, many frontline workers are going to be concerned about their jobs being replaced. So that's another side of it too. And then transformational leadership, organizations having that key role or that key group that leads transformation for the organization, change management, and ensures that their outcomes or their goals, what's top of mind, is aligned with the leadership of the company and the board of directors.
Okay. So in our conversation so far, I've heard us talk about automation in the front end and the back end. I've also heard us talk about unification of data as a key challenge on getting to automation, and then data containment, and then cultural shifts that come with implementing all of that. Do you have any final thoughts you want to leave our audience with before we let you go?
AI, is a concern for many people. At the same time, leadership at many organizations want to embrace AI, not for this, not so much for the purposes of reducing their cost structure, but more so for how do I get that competitive edge? How can I move business at a velocity that makes us competitive in the marketplace? So I think it's a strategic. We need to embrace this, just like we embraced .com in the 90s. Okay, AI is that next big wave. It's actually bigger than .com from that standpoint because it's going to connect and provide insights across the entire landscape and across the entire fabric. And I think it's going to take us another 5 to 10 years to truly embrace all of the possibilities that AI can do for us. And then also at the same time, organizations like OpenAI, they keep evolving their technology stack, and there are new organizations that are coming out as well. Okay, and Microsoft's doing a lot in this place. So while the solutions keep moving forward, at the same time in parallel, organizations will think about how they can take advantage of that to better their organization.
All right. So don't fear the change, embrace it is the final message here.
Yeah.
All right. That seems like all the time we have for today. Rody, thank you so much for being here and sharing your insights with us.
My pleasure. Thank you.
Diana, Rody, thank you very much. Up next, we'll move on to our partner keynote by Kevin Cochrane from VULTR.
Hi, everyone. I'm Kevin Cochrane, Chief Marketing Officer here at VULTR. VULTR is pioneering a new public cloud platform that combines the best of cloud-native compute with GPU as a service to help businesses speed the development, deployment, and on-demand scalability of AI-native applications across 32 operating regions across 6 continents all around the globe. And just now, we heard a lot about the promise of AI to automate a lot of front-end processes related to sales, related to marketing, and related to customer self-service. And what I'm here to do today is to talk about automation on the back end and how we can unlock the power of generative AI to enable developers and IT organizations to empower the business with all new front-end applications and automations to deliver exceptional customer experiences. And over the course of the past 10 years here at VULTR, we've pioneered cloud-native compute. And as part of that, we've learned the core principles for how to automate the provisioning and deployment and scalability of infrastructure to support some of the most demanding workloads on the planet. And as we look forward to the next 10 years of rebuilding our cloud-native applications to harness the power of AI, it's very critical that we look at the 5 key principles of automation that need to be brought to bear as we look to deploy GPUs worldwide for training and production inference. So let's start with the concept of composable infrastructure. In the core cloud-native engineering world, we've pioneered certain principles related to API-first architectures, containerized workloads, built-in observability of governance, and most importantly, an automated process for DevSecOps, where we can employ infrastructure as a code practices to automate the provisioning of infrastructure on a worldwide basis to help our applications run and reach our customers. And not surprisingly, what over the course of the past 10 years we've built is, again, an automated pipeline where we can take any containerized business logic from any public registry and then provision it through an entire life cycle where we can ultimately speed the deployment to all regions globally in order to support the production runtime deployment to our end users. And in the cloud-native engineering world, the things that we don't worry about is manually provisioning infrastructure, our virtual machines, our bare metal servers, our storage, our databases, our networking. It's all captured in core configuration files that are automated as part of a workflow to automatically spin up and deploy the supporting infrastructure to deploy all of our containerized application logic all the way to the edge so that as customers are interacting with us, we can provide minimal latency, best performance, and we can reduce risk and reduce our cost of operations. In the cloud-native world, automation rules the day for production deployment of all of your code artifacts. And these principles of automation need to be brought to bear in the AI world. Now, in the AI world today, most of processes are all related to manual procurement, manual provisioning, and manual operations for standing up GPU clusters for purposes of training. We need to keep in mind the core principles that we've learned from cloud-native engineering and bring it forward to the AI generation. We're now dealing with API-first inference models. Our containers are not application logic, they're models. we're not just doing observability for our application code, we're doing observability for the outputs of our AI models so we can build trust. And we need to integrate an automated pipeline of AI ops, where again, we can apply principles of infrastructure as a code to eliminate all of the manual processes for standing up training clusters, standing up inference clusters on a worldwide basis. So here at VULTR, what we're pioneering is a new API-first architecture that takes all of the best infrastructure as a code practices and for the very first time applies it to GPUs at global scale. So you can take any containerized model from any public registry and implement an entire pipeline where you can actually go through your full tuning, fine tuning processes, and ultimately deploy all of your GPUs across 32 operating regions of the world for production inference. Again, eliminating all manual steps that are time consuming, error prone, high cost, and introduce significant risk. Moreover, it's critical in this new GPU as a service world for public clouds that we integrate the GPU pipeline with the CPU pipeline so that we have one integrated automated pipeline for provisioning our code artifacts and our model artifacts to all of our endpoints all around the globe. And so what we do believe is one of the core principles is embracing the notion of composable declarative infrastructure, where your platform engineering teams can build a simple config that enables the automation of one integrated DevSecOps pipeline that can provision all of your CPU-based infrastructure, deploy all of your containerized application logic on Kubernetes, as well as do the exact same thing for your GPUs and your containerized open source or custom-built AI models as well. And to do this provisioning all the way to the edge so that wherever your employees, wherever your customers live and work all around the globe, that you can deliver a superior experience that delivers against their expectations. The second key principle is we need to think about automating a hybrid cloud infrastructure. We just heard a little bit about making certain that you have a common backplane against which your AI models can operate so that you can automate all of your front-end processes. For many organizations, the centralized data store, they are going to be maintaining on premises. And in so doing, we need to automate the process by which models can basically tap into centralized data sources that exist internal to the organization and in a safe and secure way through a hybrid cloud deployment model, automate the training process, and then ultimately the front-end provisioning of those trained models for tuning and production inference. Again, automation is not just about provisioning the infrastructure, it's also about provisioning the networking so that you can integrate your current locations where you actually are storing your data so that they can access public cloud infrastructure and your GPU training clusters for purposes of training those models that you're going to be deploying to production inference. Furthermore, when we look at deployment models for AI native applications, we need to, again, take the best practices learned from cloud native engineering, which is we need to move to a serverless infrastructure. Because when we're thinking about deploying our models to production inference, we need to automate the on-demand scalability in the runtime environment. Regardless of how you can forecast demand for your workloads and the locations where you expect your consumers and employees to interact with your applications, at the end of the day, you're going to suffer a lot of variability. And in the traditional cloud native engineering world, we don't really worry about this because we have the benefit of serverless infrastructure that supports that on-demand scalability. In the GPU world, why do we not have the same thing? Why do we not have a worldwide inference fabric so that when we're deploying our production models, we can automate the scale up and scale down without having to be declarative on what resources where need to be deployed. And in the VULTR world, what we believe firmly is that based on incoming workload demands, we should automate the scale up and scale down of the appropriate GPU in the appropriate location at the appropriate time to deliver the best possible performance, the minimal latency, the lowest cost, in order to make your applications deliver the end result that they need to their customer. This is all about taking the third principle, serverless, and making certain that we integrate serverless automation in all of our production pipelines for our AI models. The fourth point is automating the process by which we can deliver contextualized results from our AI model. And this is all about implementing retrieval augmented generation, RAG, and automate the provisioning of vector stores all the way out to the edge so that we can incorporate the corpus of knowledge from our organization to fine-tune the context before any results are actually delivered to the end customer. And what this means is that as part of our automation, where we need to deliver contextually relevant results, our pipelines, our automations should automatically incorporate all of our knowledge sources from within the enterprise, generate embeddings, put those embeddings in a vector store, make sure those vector stores are globally distributed to handle any incoming request so that any output from our AI models can be fully contextualized to deliver a hyper-personalized response to the end user. Again, today, in the AI world, all of this setup, all of this configuration, all of this management, all of the observability and monitoring, it's all an error-prone, manual, time-consuming process. This should all be automated. This should all be automatic. There should be no risk. There should be no additional cost. Nothing should be manual in this entire value chain. And lastly, after delivering that contextualized response, we need to make certain that the entire pipeline is something that can be audited and is something that can be trusted. And here at VULTR, we believe very strongly that in this new world of generative AI, putting in place best practices for security and for compliance needs to be built in from the ground floor. And this means as part of your pipeline, every step in that pipeline, every piece of networking and storage and compute infrastructure, GPU or CPU that's being provisioned, all need to be part of an integrated SecOps pipeline tied to your DevOps pipeline, tied to your AI ops pipeline. One integrated pipeline, full observability, full control, full adherence with any governance framework put in place by your CISO. And so again, here at VULTR, we believe very firmly that to unlock the promise of AI and automation on the front end for all of your sales, marketing, and customer service functions, we need to look back first at the core infrastructure and the automations that need to be put in place by your CIO and your platform engineering team so you can eliminate all of the manual processes and you can reduce risk, reduce cost, and deliver a superior result to your customers by building in place all of the 5 key automations from composable infrastructure to hybrid cloud infrastructure to serverless compute to RAG and to compliance in order to advance this next generation of AI native applications. And again, here at VULTR, this is what we're helping customers to do all around the globe, all 6 continents, 32 operating regions. And we look forward to discussing automation for all of your DevSecOps pipelines in the future. Thank you so much.
Kevin, thank you very much. Now we'll move straight on to our panel discussion, which will be moderated by Roy Chua from AvidThink. Roy, over to you.
Thanks, Oliver. Excellent. So we have a panel of experts, as always. Always very I would say, very honored that we have a lot of folks with deep expertise in cloud. In this case, we also have telco expertise and certainly automation as well. So we're going to get started by asking the panelists to do a very quick introductions of themselves. Let me go in order. I'll start with Paul. Paul, introduce yourself, please.
Yeah, hello everyone. So Paul Grønsund. I'm working as the lead on cloud strategy and architecture within Telenor Group. Great to be here.
Excellent. Thank you, Paul. Up next, we have Nandan. Nandan, if you could introduce yourself, please.
Hi everyone, I am Sree Atur. I head the Rakuten Cloud Native Orchestrator for enterprises and telecom with hyperautomation, security, observability, and recently machine learning.
Excellent, thank you. And that's the keyword, machine learning. Next up, Ildiko, if you could introduce yourself, please.
Yes. Hi, my name is Ildiko. I am Director of Community at the Open Infrastructure Foundation. The Open Infra Foundation is a nonprofit. We are supporting open source software development communities like OpenStack, Kata containers, and more. And as part of my role, I focus a lot on collaborative software development and helping companies to strategically invest in open source. And I am a community manager for 2 of our projects, Kata containers and Starling X.
Excellent. Thank you, Ildiko. And Ram, if you could introduce yourself, please.
Yes. Hello, everyone. My name is Ramanathan. I represent Ribbon Communications. I'm a Senior Director of Product Management, and my responsibility is with security, cloud native, and automation at a high level.
Excellent. Thank you, Ram. All right. So today's discussion is going to be 3 parts. We have about 45 minutes of discussion here. I'm going to start with some of the precursors to automation. Certainly, you can't automate, without some of those prerequisites in place. So we'll talk a bit about that. Then we'll talk about automation across complex cloud architectures. Now, some of today's discussions may be a bit more telco-centric because we have many experts here who have telco expertise on top of cloud expertise. But a lot of the discussions are just as valid for any enterprises or any data center operators. So, I would say, adapt that learning accordingly. And then finally, the last part, we'll get to sort of the cool part. I don't think there's a panel on this earth right now in technology that doesn't have AI ML on it. I mean, every panel has to have AI ML. I didn't expect to see RAG this morning, but I saw RAG and vector databases. I think it's going to be part of every session, at least for the next 12 months. So the last part is going to be ML and the application of that to automation. So let's get started. We'll talk about precursors first to a successful automation. I'm going to start with someone with actually feet and hands on the ground working in the field there and understanding what's the real world scenario. So in your experience, Paul, what are the key factors required to lay the groundwork for successful automation in telco environment, and obviously works beyond that as well, particularly around cloud transformation? And I know one of the key things that I know telcos talk about is the right organizational culture. And actually, Rodi talked about that in the first discussion as well. So Paul, go ahead.
Yeah, no, thanks. So I think, I agree. I think Rhoda in the first session there had some really great perspectives on the organizational and culture, addressing things like the operating model, cloud center of excellence, and also the product leads and so on. But I think maybe if I try to put it a bit into a holistic context for an operator like Telenor, the transformation concerning zero touch, if as we call it, which can also be looked at as the automation, right? Including cloud, autonomous networks, and so on. It's also a lot about achieving everything as a service. And of course, one step towards achieving everything as a service for us is on delayering the organization, such as delayering into the infraco, netco, servco, and the kind of the model also coming from TMF.
Yes.
So, but I also still think that this as a service thinking also needs to be in place within these individual delayered organizations too. So if you look at kind of an example where you have, say, for us then, on the infra side, you have a facility team which provides space, power, and cooling as a service to a cloud platform team, which then provides cloud services as a service to application teams and so on. So obviously, in order to achieve that as a service model, there needs to be a lot of automation within each layer. So I think that organizational structure is really a tool to execute on a strategy. But in the end, as Rod also pointed to previously, is that the operating model is really important, which concerns the people, processes, and the tools. So if I were to touch on kind of the what I would say is maybe the most challenging and demanding and what desire most attention would be the people part. How to change the mindset, putting automation first, everything as a service first in whatever you do, and how to kind of build a culture embracing this change and way of work. So in order to get there, we put in place training, we're having top-down attention from the executive level, working with partners such as the hyperscalers, which are quite good at knowing what it takes to get there. And so that's some of the learnings we have, and obviously also embracing the DevOps or DevSecOps, which is really a culture that needs to be brought in to enable that automation. And I know Kevin talked about that in the previous session as well. So I think that's a bit on it. Of course, I would love to take the technology part of that transformation as well on cloud orchestration, AI, ML, but let's park that for now and take it up later in the discussion, I would say.
Yeah, I think we're going to get to that. But I think what you point out is really important. I think that the cultural elements are critical, and having the right mindset, because you're not going to get people to automate, and it has to be distributed across each of the different organizations, even as you delayer the organization, as you point out with Telenor and many of the other telcos doing the same thing. And I think it applies to large enterprises, the same thing, distributed approach to it, and decentralized in some situation. But in order to make that happen, there has to be a culture that's set appropriately. Speaking of culture and people, open source, and open source communities have been a big part of the cloud. I mean, look, Kubernetes is open source, OpenStack is open source, right? Linux is open source, right? So how can open source solutions perhaps contribute to creating a foundation for automation across infrastructure, telecom, and otherwise? And maybe, Ildiko, can you give examples of how some leading projects can facilitate this?
Of course, I'm excited to talk about open source in this context. And I think the answer is really multi-layered. So you already mentioned OpenStack and Kubernetes and the Linux kernel, which are all open source projects. And the relevance of the open source ecosystem on one hand, when it comes to people and culture, is that everyone has access to both the source code, but not just the source code, but also the community and the ecosystem around it, so you can talk to people. So the knowledge sharing part of open source is actually really huge. And I think a lot of people overlook that how much it matters that you have access to experts all around the globe, and they don't have to work for the company that you work for. And you can still talk to them and understand, get a better understanding of both the basic concepts as well as how a particular specific project works. And when it comes to the technology side of open source, you can see how all the layers of a modern software stack are covered through open source software. Like we talked about the Linux, or mentioned the Linux kernel, mentioned OpenStack as an open source cloud platform. And we actually do see an uptake again in OpenStack. So the user base for the project keeps growing. A lot of organizations have been migrating, for instance, from VMware to OpenStack based clouds. And having access to the community, people can understand much better the fundamentals of cloud computing, which will then allow them to be able to automate both how to manage the infrastructure as well as onboard applications on top of it. Now, if you need OpenStack in a geographically distributed configuration, then you don't need to implement anything yourself. You can go and pick up Starling X, which is an open source project that is a distributed cloud platform, and it creates a fusion between OpenStack and Kubernetes. So all the services are containerized, which makes the platform more manageable and robust. And the community has been working a lot on the automation concepts to build into the platform. So it is all accessible again in open source under an Apache 2 license, and you get OpenStack as well as Kubernetes in a geographically distributed configuration, which those projects cannot really do by themselves. So you need additional components, which StartingX does give you. And I also want to throw in Kata containers from the perspective of, as much as I know, it is still a practice in telecom networks to run containers in virtual machines for that isolation, security, and for other considerations like multi-tenancy. Now, Kata Containers is a project that gives you containers in a really thin, lightweight virtual machine. So although it's not necessarily automation in the activity sense of things, but it saves you a step of spinning up the virtualization layer and then put the container into it yourself. So you can look around in the open source ecosystem and find the solutions that will give you what you need faster in less components, and maybe projects like StartingX, which already baked in things like the zero touch management, remote management of components and large systems, and start with that strong foundation.
Excellent. Well, thank you, Ildiko. And I think, a couple of things that you pointed out are really important. First of all, there's all these building blocks that exist, and many of those building blocks have automation built in. And, why reinvent the wheel if the wheel's already there for you to pick? And there's many sizes of wheels that you can pick from and many colors and shapes. So go ahead and pick, StartingX or Kata or, OpenStack itself or Kubernetes available. And I think the second element is that there's a lot of people in the open source communities that are good at collaborating and have a lot of culture of CI/CD, and either recruiting or tying into one of those ecosystems can take you a long way in terms of setting the right culture and the right mindset for automation. So excellent, thank you. Now there's one other thing that I know is really, really important in terms of automation and scalability of these platforms, and that's APIs. Now we talked about APIs for many years now across the board, and APIs are a core of what clouds are driven by. And I know recently in telco, there's this whole API movement that, was there previously, a couple of waves. This is probably the third or fourth wave of API, but it looks like it's really happening this time. And so perhaps from a vendor's perspective, how crucial is the availability of APIs in enabling effective automation? And what steps should vendors take to ensure products are automation ready, right? I mean, obviously, products that are not automation ready or automation friendly, make life difficult for the telcos and enterprises. So Ram, what's your take on that?
No, thanks for the question, Roy. I just want to highlight a couple of things that Paul mentioned before I get into the API question, because this is really important, and Paul said it really well. Just want to reiterate that there are technical challenges, there are cultural challenges, right? And technically, any organization, any telco should be aligned, top to bottom, left to right, that this is what we want to do from a cloud native perspective, from an automation perspective. Without the alignment, it's going to be very difficult to achieve some of the low hanging fruits and then build from there, right? So alignment from a technical perspective, cross organization needs to be there. Expectations need to be set pragmatically. This is not a forklift from where you are to where you want to go. It's going to be built in steps. So the expectations are key, right? And the other thing is the cultural aspects that Paul touched on is the people, people are part of this. Even though we call it automation, people are absolutely part of this. And the skill sets of people may need to be enhanced. The transformation steps need to be laid out, and it's different for different organizations in terms of the evolution journey. So really the technology and the people go together, and the expectations need to be set the right way, and alignment needs to be there across the organization. And that's when this thing can be successful, right? So just wanted to highlight that. Now, from an automation perspective, I clearly would like to talk from a vendor perspective. APIs and automation ready, how do we build products, things like that. But at the outset, automation is a very broad term, right? You can dump pretty much everything into automation, right? And one of the big challenges, I think, with vendors is, as a community, is that we need to think about automation not just from the perspective of our own products, right? It's not just our own products, because every network is going to be multi-vendor, every network that I've seen at least. So we need to think about this from a customer usability perspective, not just how our product is going to work, but how is the customer network going to work. And the key vision of automation should be to design this with customers' usability in mind, customers' processes, their ecosystem with different vendors, how they're connected together, how do they test things, how do they take things from lab to pre-production to production? What is the process? What choices do they have? I mean, Ildiko talked about open source components. What are the open source components in the customer's network? How do we integrate with that back-end ecosystem? So we need to look at this from a customer's perspective, not just from a vendor's perspective. And then we need to break this down into, we call it pipelines, right? We need to break down the automation into steps. Could be provisioning automation, could be test automation, could be upgrade automation, canary upgrades and rollbacks, things like that. So we need to look at each of these steps that a customer takes today without automation, and then kind of go along the way, low-hanging fruits first, and then build up the confidence and the momentum, and then try to automate as much of these processes as possible. And also interoperability. How do we connect into the telco's backend, observability, orchestration, analytics? We talked about data in the first part of the presentation. How do we link into a common data repository? What are the compliance issues? So we need to look at all of these from a multi-vendor perspective, from a customer's perspective. And hopefully at the end, when we do this right, there will be a real benefit from an OPEX and CAPEX perspective for the telco. So I think the big message is I think vendors need to look at this from a customer's perspective.
Yeah, I think that's a good point. Not look at it from your perspective, but understanding how someone like Paul or Telenor can actually consume and actually automate all the vendor products interoperability. And this is obviously, as you point out, there's a compliance aspect. There's a lot of other elements that are important. All right, that takes us to sort of the second phase of the discussion. We've talked a bit about sort of the precursors, the prerequisites, some of the elements and things to consider. And certainly, culture is part of it. Using existing open source capabilities out there and having the right mindset is important. Let's talk about automation across complex cloud architectures, which is the reality. Whether you're actually cloud enterprise or telco, that's the reality. So perhaps, Nandan, can you examine the evolution of automation, in telco networks from maybe the traditional architectures to today's, it's actually a distributed cloud environment in some case, right, with a RAN attached to it. How has this progression influenced automation strategies?
Absolutely. So to understand the automation essentials, let's step back and take a look at how the network has evolved in the last 40 years from 1G to 5G. Yes, it began in 1983. So we'll take a look at from two perspectives, the user and the network. So with 1G, there was only voice. With 2G, there was voice, static data and text. With 3G, there was real-time face-to-face communication and video streaming. With 4G, there was high definition video content and video streaming as well as online gaming. And with the capabilities and speeds that it offered, not only mobile phones, but laptops, tablets, and IoT devices were connected to the network. And with 5G, we have ultra high definition content on the network, as well as your LLC and massive machine to machine type communications, which opened up possibilities for Industry 4.0, smart grid, smart cities, and maybe even autonomous driving in the next few years. So the type of communication and the depth of communication has significantly progressed in the last 40 years from the perspective of the user. Now let's take a network perspective. So there are three things: the infrastructure, cluster, and applications. 1G started off with everything proprietary, hardware and software. And in 2G, there was maybe a use of well-known operating systems. 3G, around that time, the virtualization concept began popular, and there was a very low adoption of virtualization in the form of maybe VPNs and PNFs, and even server virtualization. 4G, where there was massive adoption of virtualization, along with the servers, the RAN and core was virtualized, and the network was completely virtualized. In 5G, there was a paradigm shift towards being cloud native. So Kubernetes became the default orchestration platform to orchestrate both the VNFs and the PNFs, the CNFs. And the way everything was operated by the network, there was a paradigm shift to being everything Kubernetes style. So the way it was done in 4G changed completely towards 5G with Kubernetes operators and observability. So things have naturally progressed, and there's tremendous shift in technology in the last 40 years. Now, automation plays a very key role in how the networks are built, configured, maintained, operated, and even monetized. So building a site because of this massive network where there are billions of users and devices, the rolling out of the sites has to be super fast. So it should be as fast as racking and stacking the server, scan a barcode, which will spawn an automation workflow, and right from the BIOS to the network service will be up in a few hours, which means that the site is up and running, it is radiating, and the live traffic is flowing in a matter of hours. Now, when we are configuring each site, there are thousands of configurations across the infrastructure, cluster, and applications, and it has to be organized very neatly in the form of profiles and templates so that everything is done in a seamless fashion. Now, managing these thousands of configurations at scale across the sites, geo-distributed sites, is a big challenge. And that is where GitOps style of management of configurations centrally by detecting the drifts continuously and resyncing the configurations is the key. Now, when there are like millions of network elements in the network, you need to have a granular view of what exactly is happening on each of the network elements per site and across the sites. So that means you need visibility, you need insights, and deep observability. So that is when you start to collect data in the form of metrics, alerts, events, logs, traces, and energy every few seconds to exactly figure out what is happening and what might happen. And when the network is having billions of users and devices, as Ram mentioned, upgrades are super important because the network cannot be disrupted at any point in time. There is a requirement of having 4 nines or 5 nines uptime on the network. So the upgrades, both on the hardware and the software, has to happen in such a way that the network is not disrupted. And with such massive network, the operator has to make money and it has to be monetized. So everything has to be running efficiently. So there has to be optimal usage of resources, optimal support, quicker resolution to issues. And we have to step back and take a look at fault management because it is no longer reactive or proactive, it becomes predictive. So you have deep data that is collected and it gives you analytical features wherein machine learning and predictive analytics can become the key.
Excellent, and we'll talk about predictive analytics and machine learning in our next section coming up soon. But yeah, I think I like the points that you brought up here, especially around the reliability, just on the sheer scale itself, and the importance of gathering data, observability, all very important in supporting automation. Now, given the kind of scale, given that kind of distributed number of elements in there. Obviously the old automation, automation is important, but, sort of the script-based, line by line automation doesn't quite cut it anymore. So how are declarative and intent-based automation changing the landscape of network management? Maybe, you talked about Kubernetes, and we've talked about Kubernetes, right? Particularly in the context of, say, Kubernetes and GitOps. So Paul, how are these things changing in terms of managing complex cloud architectures?
Yeah, no, it's a key point for sure. I think, intent-based automation and, of course, related APIs, as Ram talked about, is really necessary in order to achieve autonomous systems and autonomous networks as we have as key strategic directions. So, if you look at intent-based automation, like basically the way it works is that you basically tell a system how you want your service to behave by using some sort of an API and probably some standard data model. And then the system should take care of the rest, like scaling, optimizing, healing, and those type of things. And that's like referring back to what I talked about in the first question is really what we need to realize this everything as a service strategy. So then a bit back to Kubernetes, right, which it is an open source container orchestration tool like Ildiko explained, and also Nandan talked about. It's really a key enabler for this declarative automation. And the Kubernetes operator framework, I know Nandan talked about that as well, but I think I also want to highlight that because that's really what we use in order to write those operators and the CRDs to extend that Kubernetes API for new services. And if you do that right, these services can then be managed using intent-based APIs. And what's also really interesting, right? Because usually we think that only the things we put in cloud can be made intent-based, right? But the thing is that this framework you can also use to write Kubernetes operators for systems not running in the cloud, right? So you can get those managed in or automated in a declarative fashion, which is quite interesting, I would say. So then, but also putting the GitOps in there, right? Because GitOps it's really a process, or call it an operational framework, which is becoming, and it is fairly standardized to automate cloud infrastructure, like, and also systems and networks. So I will not go through how that works in detail, but you push your code into a Git repo, then after testing and approval, it is getting automatically deployed into the infra, leveraging security policies and so on. So I think like GitOps is for us a key part of the automated CI/CD process, and they're also really important part of which is what I talked about as the DevSecOps culture that we are trying to bring. And wrapping this up together, right, as back to the key part of your question, how is this important to manage the complex systems? I would say both intent-based and GitOps is like not only nice to have when it comes to really complex systems, it's really a must-have for us. This moving into cloud native with thousands of microservices running at the same time.
Yep, no, agreed. Thousands of microservices, millions of network elements or more, right? Tens of millions of network elements. There is no way to programmatically go into each one and say, you do this, you do this, you do this. It's more like we all have to be here. Now go figure out how to get there, right? On your own. Right?
Exactly.
That's the element of it. Very, very good. Excellent. So, speaking of that, this kind of scale and this kind of automation, and I think, Ram, you talked about interoperability, you talked about multi-vendors. How do you envision this kind of vision being implemented, across a life cycle of products or services, in the context of that multi-vendor interoperable, framework that you talked about earlier?
No, I think that's a great question, Roy. And applies to almost all the telcos, all the enterprises, the big enterprises, applies to all of them, right? So it's a great question. Just to follow up on what Nandan said, in terms of where we are and where we need to go, carriers are in different stages of evolution. Some are on the physical network, some are on virtual, and then some are bleeding into cloud native. So everybody's in a different domain, different paradigm at this point. So almost like no network left behind. We need to design products and processes. So we not only look at the cloud native telcos, but we kind of carry the physical and the virtual telcos into the cloud native world. So we need to design the processes so we don't leave anyone behind, right? With that in mind, in terms of interoperability and simplicity and how do you make this work, multi-vendor network work, so one thing is multi-vendors. Every network has many different vendors that come together to make a solution work. But also, as Ildiko mentioned before, the open source aspect of this. That is becoming more and more prevalent in the cloud native world because, if there is something available, some of them may be no charge, maybe with support, some of them you got to pay for it. If something is available that is best of breed, why reinvent, Roy, as you said, right? So now it's not just multi-vendors, there are multiple open source applications. How do you bring all this together and make it work, right? So again, just going back on my other answer, we as vendors need to look at the customer usability, not just look at our own products, but how do customers use this? How do they put together this entire solution? What are the processes they go through? And obviously the bigger carriers, they pick the best of breed vendors. The smaller ones may pick one vendor to do it all, but most of them, they pick the best of breed so they get the best solution out there. Multi-vendors, so there is competition and so on. So as a community, I think we have done really well on the product interoperability, right? With the technical interoperability between protocols, helped by the standards bodies, obviously, IETF and so on, right? So 3GPP and so on. So the product side interoperability has been taken care of in most parts. What we are lacking is this going into the new world of cloud native, automation, observability, data. The Microsoft gentleman talked about data. How do we kind of make them gel together, right? Because there's no real standards out there. There are some high level, but there's no real standards governing these things. And then how do we make this pluggable into a larger backend ecosystem? Because no vendor is going to control the entire end-to-end ecosystem. So how do we plug into that backend ecosystem with APIs? So all of this becomes key from a multi-vendor perspective to make sure that we not only look at our product as, let's say, from a test automation perspective, our product from a unit test perspective, just test our product automatically. We need to test end-to-end call flows, if you will, right? Which may have the RAN, in the case of wireless RAN, packet core, IMS, and so on, right? So how do we test this network end-to-end, which has many different elements and many different vendors in the mix? So while unit testing and unit configuration has its own importance, the end-to-end automation should also be kept in mind as we work with the carriers. With the tier one carriers, for example, we do a lot of planning, and the planning is important here, not just the implementation, but the planning on how to design these frameworks between the vendors. What are the interfaces? How do we interoperate? Those things need to be really planned well, document requirements, and then go forward with implementation. So really key for the end-to-end automation to work here.
Excellent, and that's a good point there. That forgot to talk about testing, right? In any kind of automation framework, the testing is important. The end-to-end testing is important because it doesn't matter that the RAN is up or the transport is up, the core is not working. It doesn't matter. The subscribers have no service anyway, right? So that's a key point. So I think the discussion so far. We've talked about some of the precursors. We talked about some of the key elements, and certainly there's a lot more to explore in terms of automating these complex, sort of cloud native, along with the physical and the virtual, network functions that haven't been all cloud nativized, so to speak. I think bringing that all in, as Ram says, no network element left behind, right? That's what we want to do, right? In terms of the networks, because not all networks can be greenfield, right? There's the vast majority of networks out there, whether it's wireline or mobile, are brownfield, and automation can't just say, I'm going to automate 50% of the network. The other 50%, good luck, right? Not quite. That's not quite the approach we can take. Now let's move on to the last part of our discussion. So we'll wrap up in about sort of 12 minutes here. AI ML, right? Now, how can we approach AI ML from automation in a way that's practical, not just this pie in the sky, speculative? Yeah, one day AI and ML will automate everything, and you don't have to do work, but you just sit there and collect your salary. That's the great thing, but not going to happen. So Ildiko, how can we approach AI ML from a realistic perspective today, telcos or otherwise?
I mean, are we starting a new panel with another 45 minutes?
Yeah, no, you got like 4 minutes, unfortunately. Yeah, summarize all your deep thoughts in 4 minutes. Yeah.
Yes, AI is a big topic, and it's another multi-layer answer to your question, I believe, because you need to look into how to even enable AI and machine learning. Like, you need to be able to handle sensitive data a lot of times, for instance, because all the AI models are trained on large data sets. So this is something that we see, for example, in Kata containers, where NVIDIA is heavily involved currently, not just to plug in the GPUs to help with processing the data, but also to use Kata containers for their use case of being able to handle sensitive data with more security, because it is crucial to keep that data where you can process it without anyone else to access. And once you have the AI model that you're using, I think it's another part where cultural change and learning and training humans will also be really, really crucial, because you can't just blindly trust AI, that it will give you the right answer. Like, if you're using generative AI, for instance, depending on the training data set, you can still get into copyright issues if the model is giving you back an output that is heavily relying on the training data. So you need to be able to figure out whether or not that is an issue. If you're using things like AI assistants, that is something that I see happening more and more, like two of the core Starting X contributor companies, Ancora and Wind River, are currently partnering on building an AI assistant to work with the Starting X project. It is currently on the commercial offering side, but I think that is a great way to look into how to help with automation. And things like, it is one thing to deploy a platform on large scale in a geographically distributed manner. You can do that automatically. But when it comes to fine-tuning the configuration for your system specifically, that can still be something that gives you a headache. Or how you troubleshoot large and complex systems. And humans are not really good at reading documentation, so why don't you just have the AI to do that for you and give you some hints and prompts in terms of how to configure your system, how to troubleshoot what an issue is within a system. So I think that we can approach AI and ML in an iterative way where we have a chance to learn as well as use these tools and systems the safest way. And I think open source AI will play a big role in this, mostly on the culture and learning side, so that we have access to the models, the weights, the training data, and code behind all these AI models, or well, the open source AI models. And if anyone is following this space, the Open Source Initiative is currently leading the effort to define what open source AI is. So I definitely recommend following that activity and participate in the conversation if this is something that is important to you. And I truly hope that it is, because I think it is in all our best interest to have access to AI models, to be able to study, understand, and use them.
Agreed. So definitely, co-pilot type approaches are there, and AI ML, from commercial offerings, even on open source, available, and it's going to be an iterative approach. So great. Now, speaking of sort of some of the other elements of AI, so how do we see things like predictive analytics? We talked about predictive earlier, right? Predictive analytics and generative AI changing network management and fault detection. Ildiko gave some examples, but can you provide also maybe further examples in automation and telcos? Nandan, I know that Rakuten is doing some of this for sure. So can you share?
Yeah. So absolutely. So let's step back and see the evolution, right? So as we spoke about before, the current paradigm shift is AI/ML, but from 4G to 5G, where Kubernetes became popular, Kubernetes was started inception maybe in 2017, and in a couple of years with its meteoric rise, there was huge adoption of Kubernetes, and in just a matter of few years, it became the default orchestration platform. And everything changed from virtual native functions to cloud native functions, Kubernetes paradigm. Now, the current shift in that evolution is AI/ML. I know there's a lot of skepticism on machine learning and how it would change everything because of the expectations that's being set. Can AI drive my car? Can AI cook for me? So we are not there yet. But how is AI going to transform the telecom networks? But if we start to look at it, there's one real use case where AI is really strong right now, and that is the large language models and generative AI. And everybody has seen ChatGPT and maybe also gone on WhatsApp with Meta AI, where you can chat with Llama. It gives you real quick answers to every question you have asked. But the thing is that Meta, as well as Llama, as well as the ChatGPT foundation models, only knows what it has been trained on. It does not know the deep questions that you would ask on your particular telecom network or the products that are operating, maybe built by Rakuten, maybe built by Verizon or AT&T. So how can the user use AI/ML here? There are two ways where we can bring where this can happen. The first thing that it was also touched upon with Kevin was the RAG, which is the retrieval augmented generation. building it is super easy. So you take all the product documentation that you have across multiple products in your network, feed it to your foundation model, and that is stored in your vector database. And any questions that the user asks as to how do I do something, what is something, like for example, if you want definitions, if you want to figure out stuff, it is as easy. So think about it as a personal assistant where you can ask stuff for definitions, for how to do things, and it'll exactly tell you what to do with respect to connecting you with CLIs, connecting with you with UIs to accomplish your task. Now, automation is all about making things easy. Now, earlier we were used to terminals where you had the users using command line interfaces to do things, figure out things, etc. Then came the fancy dashboards where you had buttons and deep analytics shown to the user on the screen. Now it's all about generative AI. The intent is to ask something. So the user has something in his mind and he has to translate that to the assistant. It's as simple as that. So frame your question either how do I do X, or summarize the particular content, and the foundation model or the large language model will be able to do exactly that. Now, let's talk about troubleshooting. So, retrieval augmented generation is all about summarization and giving you feedback. But how do you actually use this to troubleshoot your network? Now, it is as simple as how we were doing before. Like with the UIs, the CLIs are already talking to the APIs in the backend, and the APIs are already built in such a way so as to give feedback to the user. Now, what we have to build is an interface which takes the natural language of the user and connect with the APIs. So you first have to build a data set, all the possible things that the user can ask to accomplish a certain task or to ask for certain definitions. So you build your data set. You feed this data set to the foundation model and fine-tune the model, this was also touched upon by Kevin. So you have a fine-tuned model that works with your particular data set. And with this being deployed in the network, you can inference at the edge, which means you can ask can you tell me in the last 1 hour which sites are down? And it might say site number 123 is down. And you can ask further questions as, can you break down the possible failures of site 123 with respect to the infrastructure, cluster, and applications? And what is happening at node number X? What is the problem with the NIC card associated with a virtual function running on this particular pod? So by making these deep connections and asking questions, you will be able to figure out what is exactly wrong with your network, and this leads to the next level of fault management.
Excellent, thank you. I think excellent summary. Predictive ML, looking at time series and trying to figure out, how to make sure your network is going to stay up and how to take proactive actions. And then around the generative AI, using context to supplement it, using things like retrieval augmentation and or supervised fine tuning to improve the model so they understand the telco domain or the data domain a little better, right? Just pulling that together and providing sort of co-assistance or co-pilot type approaches where you can query and they can assist you to do the troubleshooting. So very nice and very good concrete examples in terms of what we're seeing there. So Ram, I know you talked a little bit about security and privacy earlier in some of the conversations, so I'm going to come back to you here to sort of wrap us up here. And Paul, feel free to jump in at the end if you have any thoughts from a operator perspective. Now, as we incorporate more AI ML into automation, we know that that's coming. That's it's really happening. It's going to have more of that. How can we ensure that security is a top priority, especially in light of all the recent regulations that we're seeing all around the world? What are the key security and I would say even privacy considerations or governance considerations in AI-driven automation?
No, again, a great question, Roy, right? I think when people think about compliance and security, they think about hurdles. I don't think we should think about these as hurdles, but these as guide bars so that we are on the right track. So we should really think of it that way, not as hurdles to get somewhere. Before I get into security, I think one of the key things, I'll just give an example and that can lead into security. As Nandan was saying, how do we do predictive analytics? How can we help carriers troubleshoot and things like that? There's a concrete example that happened a few weeks ago, actually multiple examples, but I'll just talk about one. So this is a big carrier, big telco, big wireless carrier. and they're making their move from 4G to 5G, right? LTE to 5G. So in terms of no network left behind, they got to keep the customers on 4G and then migrate them to 5G while managing both networks at the same time. And there is a resource issue because, first of all, carriers are not able to hire more people because there is so much of people available in the telco sector. And, so they need to keep both of these networks going while keeping customers happy within the existing resource footprint, right? How do you do this? And there was a big issue in the 4G network as they were focusing on 5G. There was a big issue in the 4G network where in a particular cell site, there were lots of drop calls and things of that sort. And it took for them about a week for them to identify the issue and fix the issue, while lots of customer complaints and things like that. We were able to get the data and then simulate the use case. And we were able to find the issue in like 15 minutes to 1 week. I'm not saying that'll happen with every issue, but that's kind of the scale you're looking at, right? And then also not just find the issue, but the predictive analytics also tells you these are the top 2 things that you may need to fix to get to resolve this issue. And one of those things, the solution was the right solution, right? So again, this is just a start and scratching the surface, and we need to do more of this as we go forward to help the carriers. But now this bleeds into the security and the compliance. Like, what kind of data are we collecting? What are we storing? How long are we storing? Where are we storing this? Are we storing locally in the SaaS and some cloud, public cloud? So all of this comes into play. I think security is going to be a big, fundamental thing for all telcos, financial enterprises, hospitals, medical networks, and so on. Security and data compliance is key. So what they want to do is they want to upgrade to the latest and greatest releases, primarily not to get new functions, that may be a secondary thing, but to just keep up with the security vulnerabilities, right? To keep up with their security posture. So security is key. Customers want to upgrade quickly, but the problem right now is in a multi-vendor network. How do you test quickly? How do you configure quickly? How do you go from lab to pre-production to production quickly? That's where automation can help, is to get the network quickly into the latest secure release. That's where it can help. Mm-hmm. Now, from a security itself, as we look into the future, if you look at the pipeline of a network, right from getting a new release, provisioning it, testing it, deploying it, has to be automated eventually, right? Now, some of these images that we see are automatically downloaded. Software releases are downloaded. Some of these are signed, right? So we need to check on the signatures, make sure it's the right image that we're downloading and uploading into these networks. A lot of these things are key as we go forward. Now, from a regulatory perspective, you might have seen that the European Union just implemented the AI Act, which broadly defines, more from a user perspective, what information we can store, how long do we store, what kind of compliance, user acceptance policies, things of that sort. I think this is going to now bleed into other countries, other regions. Everybody's going to have their own compliance, hopefully some uniform requirements, not everything is going to be different, some uniform requirements. So vendors and carriers need to take that into account as we get into the domain of AI and ML, just to be compliant with the local, regional requirements. So we need to keep that in mind. Also keep in mind the public cloud versus private, what do we store where? It becomes very key as well. So compliance and security, let's use those as guide bars, not as hurdles as we look forward.
Good points. Yeah. Again, those are supposed to be guardrails, and they're not supposed to be blockers, right? In our place, so, and not hurdles. Excellent point. And I like that you folded in sort of security of sort of automation, CI/CD, sort of cloud. Make sure best practices are followed in terms of sign images and registries and all those things, which we all have to do. And also finally, around the governance and compliance, and we're going to have to track those, right? I mean, Europe has this, the US has this, California is going to have its own too, around AI ML, right? So we'll see what happens there. Any final words from Paul? Any thoughts that from all you've heard today? I mean, you have a large network you're running.
Yeah, I think a lot of good discussion and input. So I think on the last point on security, which is definitely a top focus in Telenor. And I think, Ram, you had a lot of good points there. Also on key consideration for AI-driven automation. I think from our point of view, it's looking at security, automation is really a super strong enabler for security. So automation enables security and enhances security. So that's our view. So I think one of the strong reason for that is definitely that the more you automate, the less you can reduce the risk of human error, which is often a cause of security holes into, say, whether it's a network protocol and the way you configure systems and everything. So that's super important. Then I think some interesting use cases that we have actually been running for many years on leveraging ML and AI somehow is like detecting traffic patterns, at least for the most critical network functions and applications in our that we have deployed, and then feeding that data to the where you run these AI ML systems to actually automate the detection and of anomalies and the security breaches in there. So that is a really interesting use case and powerful and helpful use case, I would say.
That's right. Another good use of AI ML. Okay. So with that, I'd like to thank everyone. Thank the audience for being with us today. And thank you, panelists. Thank you, Nandan. Thank you, Ram. Thank you, as always, Ildiko and Paul. And thank you to our web engineers, webcast engineers who are actually behind the scenes, and you never see them, but they do a great job and they keep all the feeds up and running and us broadcasting to you. So, all right, let me turn it back to Oliver. Thanks, Oliver.
Thank you very much, Rory, and of course everyone else on the panel. So that does bring us to the end of session 1, and let me close by thanking our partners again, VULTR, Rakuten, Symphony, and Ribbon Communications for their support of this session. Make sure you join us back here at 1 p.m. Eastern, where we'll have our next session, Defining an Automation Management Strategy. See you shortly.